Thank you, Gillian, for the introduction and also for giving me a hard time to start half an hour earlier with my speech. TK was a very good presentation and also a good introduction for me. A lot of the things you touched really also affecting our business. Let me go a little bit with you on a journey to the manufacturing and to the automation which is happening right now, and especially to the pitfalls and challenges we have. A few words about Systema. Let me share my screen. So a few words, who is Systema? Just to avoid confusion, Systema is not a toothbrush, at least not if we are coming from Germany. So basically we're doing really software-based process automation in manufacturing. So everything related to the shop floor is our business. Company was incorporated more than 25 years ago. We are independent, privately owned, ISO certified. And we're still rather small with 200 experts around the globe, but we are very international with the locations we have. And I had the pleasure to build up the business in Southeast Asia. So I used to live in Malaysia for quite a while and also helped to incorporate the company in Singapore now with a local management. And what is Systema doing? So basically we are really providing software consulting and services for automation and manufacturing. That really includes everything you need for the shop floor, from starting with the integration of machinery, do automation of processes like robotic process automation, optimize things like material transports, visualize, analyze, and the worst part of it, really do migration of existing systems, move from old to new. And having said that, Systema was born really in the front end of manufacturing. So we really started and learned the hard way and climbed the ladder and moved to other areas like assembly and test, the back end. And then even further on to PCB and electronic manufacturing services, and finally also supporting equipment suppliers around the world with sophisticated automation. So everybody at the moment is talking about revolution. I'm a bit careful about it. Let's get a little bit deeper what's going on. So no doubt there is digital transformation going on, and with a speed and a power which was just simply overwhelming. If we talk about revolution, we talk about a drastic change. So things are really experiencing a complete overhaul, a deconstruction and a reconstruction. This is something very dramatic. Well, an evolution is more a gradual change. So you start to adapt, you progress, you improve things in an existing environment, so it takes longer. And then we have the reality in manufacturing. So basically we have existing fabs and factories. And if you go to the shop floor, what you see is people, you see paper, and you see a lot of Excel in there. And the worst thing is, you can't simply switch off a factory to do some nice automation work. So everything has to be done in a running factory, which might be hard and challenging. And we see a lot of temptation right now. Like TK already mentioned, there is really a complete new set of tools and toys like AI, machine learning, IoT stuff. Computing power and storage gets cheap. And that is really a game changer. You can do much more things today than just 5 years ago. And everybody's expecting information at your fingertips. Funny thing about this one is this phrase is from 1994 from Bill Gates giving a speech and introducing Windows 95. So already at this time, this was a hot topic. So what are the challenges we see? Manufacturing has changed dramatically in the last years, and there's a common understanding that the fabs are already too complex to manage it or to optimize it manually anymore. So the complexity in the fabs is really increasing, and we see a transformation from mass production to mass customization. So product mix is going on, lot size is going down. And on the other side, to be frank, working in manufacturing is not really sexy. So we have really a challenge to get the right talents in there, and we cannot always rely on the industry veterans who are knowing everything and doing everything for the last 30 years. These people are simply retiring. And another thing is we see really that the requirements for audit from the end customers of the fabs are increasing dramatically. But this is not the worst part. What is happening right now is that the COVID situation is a big boost for digital transformation. Simply, all of a sudden, you can't have all these operators on the shop floor. So people are missing, which were doing a lot of work there. And also working from home means you have to monitor and control your manufacturing from remote. And this is really mission critical. And what we see from our customers and the feedback we get is really there's a finding, holy cow, we have hidden process automation. If you go to the shop floor and you see and watch the operators and engineers carefully, you see they're doing something which is never documented, which is not really in the MES or in other systems, because they have the expertise. They're waiting for the next lot, which they see at the previous process step and so on. And this is something you have to keep in mind if you really want to do automation. So what's the talk of the town? Let's take a short look. Bing, there is some light. What is this light standing for? People are talking about the lights out fab. And don't get this wrong, we had slides about the lights out fab in our vision 20 years ago, and people were just like, yeah, that is the future. Today, this is happening and it's accepted. And this is really a big game changer for everything we are doing and also what our customers are doing. So what do we have to do? Of course, it all starts with integration. If you want to automate and finally get to the point that you can turn off the lights, you have to integrate the shop floor. And integration really means not only the equipment. Integration on the shop floor always include different parties. So equipment for process and measurement, that's understood. So everybody does that. But if you want to go into real automation, you really also have to integrate transport and storage devices. You have to integrate all the toolings you need for the process. You have to bring the puzzle pieces together from the MES, if you have a dispatching component, recipe management, SPC, run-to-run control, whatever is needed. But don't forget the operator. There are people on the shop floor, and to make sure that the, let's say, the manufacturing runs smooth, you have to integrate them. And of course, material, not only the lots, but also all the direct and indirect materials. And so let's take the perspective of the shop floor. This is how it looks like in a lot of shop floors around the world, in Asia, wherever. And so let's look from the shop floor how automation looks like. You have a lot of tools there. You have some people walking around there. You have readers, you have the material down there. And above you have a fuzzy thing, a cloud. So with all the automation integration in there, what you always see on the shop floor are the operator GUIs, the graphical user interfaces, so where they get their instruction, type in things. So this is always a given, this is always existing. In the better case, you already have machines integrated in a, let's say, basic mode, so you can read information from the machines, get data, but perhaps not control it or optimize it. And then the best case, you have machines really tightly integrated with the ability to set up recipe parameters, to do some remote control, and really be prepared for high automation. But don't forget, such a standard shop floor GUI can do a lot of things for you if it is done well and if it is integrated tightly into also the MES. First of all, there's a golden rule. An operator should never search for anything, should not search for what is the next lot, what is my next recipe, what is the state of my tool, and so on. This should be provided via the GUI. Of course, it has to be integrated into the MES, so for the WIP tracking, so you can also integrate some ID readers in there. You can integrate it into recipe management, even there are still some gaps if you can't control if the operator really selected the right recipe. You can integrate it into plant maintenance, and you can already feed a simple version of the digital twin for the equipment. And what does it mean? Just let's take a look behind the scenes. This is what we call an automation layer. There are different ways of how you can do this, but this is always the backbone of all the automation you have to do in the fab. You see the GUIs connected in there. And then start to build a digital twin of each and every piece of equipment you have in there. Why is that? So just imagine you already are able to have these digital twins. You can set up the process parameters. You can just update the state models, take care for the maintenance and so on. And you start to do integration. Of course, you have all your components for the standard operation, for tracking, for recipe management, perhaps also dispatching, engineering data collection, and so on, connected to the automation layer. So now you want to integrate tools. What you do is extend the existing digital twin to the shop floor and start with data collection. So you don't have to change anything up here in the automation layer. You just have to expand the single digital twins, add more functionality, add physical interfaces, extend the state models in there for data collection and so on. And you can also do the same with full integration. So really control the machine, set up recipes, parameters, and so on, do a remote control start. This is the architecture to do some automation. And some of the guidelines and rules we learned during all these projects we did in the semiconductor industry around the world is having the right architecture is really mission critical. And that means you have to have really clear encapsulated function modules. Why is that? If you are able to separate functionalities with clear interfaces, this makes migration or extension of functionality much, much easier. So everything communicates via standardized interfaces on a standardized bus with each other and can be extended. And very important, this is often a challenge we see on the shop floor, decouple the user interfaces from logic. Avoid these kind of fat customized clients in the shop floor. This is a nightmare in terms of central management of all these components, updating things, changing some business processes in there. Try to avoid this. And if you're talking really about a bigger fab, you have to have a reliable automation architecture. And that really means, don't get confused by it. You don't need to have a PC for every piece of equipment. That's not needed. You have to make sure that everything you deploy in the fab can be really done from a central position. So you can maintain it, you can update it. So don't walk around on the shop floor with a USB stick and do updates there. That's impossible. You die of all the work in there. That also means you have to have a set of monitoring tools to test, to debug all the applications you have in there, and you have to make sure with these kind of automation architecture, you really can extend the functionality step by step in a running fab. You don't have to shut down the fab to do some more automation. Do it in a running fab. So what about legacy equipment? So if your machines already have 6Gem or something like that, that's fine. So it's still some effort to get it integrated and really to get it also automated in terms of recipes and so on. But there's still, the further down you go in the value chain, if you go to assembly and test and so on, you have a lot of legacy equipment, sometimes also really old equipment, but you still want to have data from these equipments. And fortunately, there's IoT. But IoT is not that sexy. It looks like just hardware, wires, and all the things you need. So this is a little bit from the playground we have in our company. So we are also applying IoT at our customers. What is really good news is that all this hardware is affordable. You can even play around a bit, and if it turns out it's not really the thing you like, you can just get rid of it, try something else. So this is not a big investment any longer to implement IoT, to integrate things on the shop floor. And even more, to integrate this by software, this is no rocket science any longer. You have stuff like, for instance, the Node-RED. This is open source. You can really click, drag, and drop functionalities. And it serves already a lot of purposes, not highly sophisticated automation, but to start with and get your tools integrated into the system to see what they're doing, and also to collect data, do all these nice analytics. This is a perfect starting point. Automation's worst enemy, paper. Paper blocks automation. So the guideline is get rid of paper. And paperless has quite some consequences if you do it right. So the first thing is Paper should not carry any information for the lot and traveling with the lot. If you have that, you have a problem with the automation. But it can be even worse. If the operators or engineers start to write information on paper on the shop floor to collect data, then you are in even deeper trouble. And the worst thing which has happened, never execute handwritten information in your manufacturing. Just imagine you have an order and have to prove what's happening, and the operators are passing information from one station to the other on the paper, which is executed and never documented in the system, never traced, never tracked. This is mission critical. You have to avoid that. But you have to have a migration path. And at the beginning, there's human interaction needed. But you have to make sure that all the relevant information is really in the MES or other applications. So everything you need to execute a lot, to collect the data, has to be in your automated systems and the automation software. And of course, if there are still humans involved, there must be enough user interfaces in there to interact with the system so that they can see what they have to do and that they also can type in information about incidents and so on. There might be a last piece of paper, which is really the lot ID, which will be traveling with the lot. And sometimes also for migration to get the operators and engineers on board and to prepare for the automation in the background. An electronic traveler can be really helpful. So don't be ashamed of that. That's a standard procedure to move on. But if you're going to real paperless, then it means we have to identify our lots by IDs, and mostly by carrier box tray IDs, so that there is no reprinting of lot ID to be done, that there's no movement of lot labels. But this raises another challenge. If you have to maintain a relationship between a box, a carrier, a pod, a tray, and your lot, somebody has to maintain this association. And in standard automation environments, so even in an MES, this is often not taken care for. So you have to add new components, tracking systems who are tracking the relationship between carrier, lots, substrates in there. But doing this and implementing these kind of solutions, you really can run multiple carriers per lot, which is a requirement, and later on even multiple lots per carrier, something we do really at some of our customers on the front end. Pretty challenging from a lot of perspectives, but it's possible. There are drawbacks, so you have to be aware of. So if you do this, it's difficult to identify a lot by just looking at the carrier. Just people walking around and see there are lots standing around, they cannot identify what is this lot about. So you have to have tools to help to get information, make sure that this is not happening. If some material is moved between carriers or boxes without any tracking, then you have a real problem, because this screws up all the relationships. You have to make sure that there are no manual interactions which destroy the relation between the box, the container, and the material inside. And of course, it helps if the material inside the container, the carrier, the tray is identifiable, so that you can also synchronize again and sort and map and do an automated verification. TK had already touched a very interesting point. Fortunately, I don't have to go too deep into this one. It's advanced analytics. To do advanced analytics, you have to start to get rid of the data silos you have in manufacturing. If you look at today's shop floor, you have a lot of different data sources, and you have a lot of silos of information where this data is accumulated, maintained, and used to analyze, but these are silos with no relationship to each other. And to do this integration for all these silos and come to transform this into a single version of truth, really the data integration is key to implement all these new tools for advanced manufacturing analytics. And this means data ingestion is key. And if you're just looking at the picture at the right side with the different sources of information, with the different symbols, you have to find mechanisms to aggregate and enrich the data you get from the different sources with context information, and also to relate the information to each other to make powerful analytics really possible. So this is something you have to do. There's a lot of work. It's often underestimated because this is under the water. This is the work you have to do to get the shiny things on top of it, the great analytics and usage of the tools today. And really to apply these analytical capabilities. But if you are able to do this, you really have the chance not only to gain very deep insights into the current state of your production, but also start with forecasting, start to optimize processes, get the root cause of challenges, look back in the past, what was happening? Was there any similarity with what's happening today? So this is really mission critical if you want to apply these new machine learning AI technologies. You have to have a single version of truth for the data you get from your shop floor. Last thing, hands-free manufacturing. It's amazing. I never imagined that something like this will happen also at the assembly and test or subcons in the shop floor, but this is now happening and this is a real challenge. And if you're talking about hands-free manufacturing, we're really talking about the art of automation. Because if you do this, if you automate the shop floor completely and try to reduce the number of people or really turn off the lights, this needs a really comprehensive approach. What does it mean, comprehensive approach? All of a sudden you have to take care for all the non-productive materials. So it's not only the lots, it's not only the material on your shop floor, you have to take care for test wafers. And this is a hell of a work. You have to take care for your reticles, for the toolings of the machine. They have to be modeled somewhere. So the MES mostly doesn't take care for test wafers. You have to take care for new product introduction, for experiments you want to run on the shop floor. In a dark room, no people. That is a real challenge. Even more, there are activities which are now getting into consideration, which are never in scope before, or were never in scope. Just let me give you an example. You have an inline machine, so there is a lot coming to the input port, gets loaded, the material gets unloaded and goes through the machine, gets processed. So all of a sudden you have an empty box at the input of the machine. Right now there is no automation component, so MES doesn't take care for empty boxes. To take away this empty box on the one hand side, and also no component to make sure that there's another empty box on the output of the machine. MES doesn't do that. You need something else for that. And even worse, if you move the lot from the one box to the other box, the relationship between the lot itself and the container changes. So you have to track this and maintain this. And also your machines have to be able to inform you about it. That can be very challenging. You have to think about it before you start doing it. Unfortunately, clash of cultures. German engineering, Asian focus on chances. And that's really a big game. The happy path is fairly easy. And that's what people love to talk about and think about. But the reality is, if you go into deep automation, you really have to think about error handling. And this can be extremely expensive and challenging to really do an error-proof manufacturing. That takes a lot of effort to think about, to create the right mechanisms, state models, flows, to take care for errors. And whatever you do, you can spend a lot of effort to become fully automated. You will get into problems if you have a lot of different automation components working on your shop floor. To analyze them and tackle them, you really need new skills. So we learned this also the hard way at some of our customers. Get familiar with tools like Elasticsearch, which allow to monitor and search in a lot of different data sources on the shop floor to find out what is the root cause for the problem. The human factor is often underestimated. If you do automation, if you do Industry 4.0, you have to have a lot of stakeholders which should contribute and align. And this is not only the automation department, it's definitely not the IT department. So this kind of digital transformation is not an IT topic, it's really on the operations and all the other departments. Without that, we see projects failing because companies suddenly realize, oh, holy cow, we have to include a lot of different parties into that, and we cannot agree on things. And last but not least, things can't be successful without a strong support from the top management. If there is no strong commitment from the top management, it is impossible. You cannot win. There's no doubt about it. This has to be done. Fortunately, we get this from our customers. Sometimes there's quite some fighting and also a learning curve about it, but top management has to be involved. So where are we? We are at both stages. There is a big change going on, but it's a big chance for all of us to improve the things. And this leads me to the last slide. This is a call to you out there in the audience. Address your topics. As the colleagues from SSIA already mentioned, there's a breakout session at 1 p.m. your time zone. And please don't be afraid of ask question. Contact us, send me a WhatsApp message, send me an email, send me communication by LinkedIn. Don't be afraid of, because at the breakout session, there will be 2 of our experts from Singapore and from Germany with me, and we are willing to address your topics, talk about it in discussion. So it shouldn't be a show. And last but not least, a big thank you to the organizing team of the SSIA. You did a great job in setting up this event. I missed the stage to walk around and interact with the audience, but it's really perfectly organized. Thank you very much. And also thank you to the audience for your attention. And please feel free to contact us to shape the breakout session in the afternoon. Thank you very much.
Thank you, Rico, for sharing very useful tips and insights on making automation easier. Rico, I know you got a polling for the audience here, right?
Okay.
Yeah, so I will launch the polling from Systema to know more about the automation journey from the floor here. So now you will see a window popping up on your Zoom panel. So please click your choice and we will launch the results like 1 minute later. So there are 2 questions here. Oh, I see somebody inputting their answers already.
Wow, that is amazing. I like it.
More interactive.
Yeah. And please do the same with the breakout session. Raise your hand, ask questions, get into discussion. We will not bite.
Okay, so I think the results are quite a lot of the participants have shown their choices. So Rico, you can see the 2 questions, right? So yeah. For the first question, have you implemented IoT on the shop floor? Actually, almost half say not yet. Yeah. And the second question, the biggest challenge will be the cost pressure. Almost half also. So in the afternoon section, you will address these pain points and tips on these aspects also, right?
Yeah, and I'm still willing and open to receive your questions and your input. So this is a unique chance to just communicate with each other and share experiences.
Yeah, we still have around like 3 to 5 minutes left. So we are open to the questions from the floor now. Just now I saw somebody already like asking questions for TK. So now you can type in your questions for Rico, or you can simply press the raise hand button so we can unmute you. Oh, okay. I saw Kelvin from Luminex. Okay, Kelvin, you can unmute yourself and ask your question, please.
Okay, am I unmuted? Yeah, okay.
Yeah, we can hear you. Go
sure,
ahead,
okay, great. Hey, I wanted to go back to page 29 because I had a question about execution. And the question I had was that there's really 2 parts to this data ingestion. The first is, I look at it as very mechanical. Just figure out how to get all the data. And I think a lot of people, a lot of companies are doing this, my company as well. I think the real challenge is, how do you go from getting all of this data to turning that data into useful information? What skills are necessary? How long does it usually take before you start seeing the benefit of collecting the data and turning it into information?
Yeah, that's an excellent question. Unfortunately, it's not an easy one. So
Sure,
first of all,
that's why I'm struggling with it.
yeah, and you're not alone. So this is really a common challenge to a lot of fabs we are working in. And one of the things we learned is it's not enough to just have an understanding on the new technologies, let's say how you combust data or how you really get data. What you have to have is an understanding what is the data about. So without expertise on, let's say, the process and what's going on the shop floor, it's very difficult to make the relationship. So we have an extra department in our companies and guys from the industry who are taking care for this. So they're having a strong expertise really on what is this information about and how long it takes. It's even more difficult to answer.
So I have a lot of confidence that my staff understands what the data is telling them. But go to the next step to turn that data into actionable information, I think requires skills that generally semiconductor process engineers and equipment engineers don't have. And so do you have to hire people of those skills, or do you use consultants to develop those skills? What's the best way to do that?
Yeah, so basically, for instance, what we did, we hired people which are really analysts and are coming not from the semiconductor industry to blend these expertise to the one who knowing what are the processes about, and the other ones who are having a fresh look from the outside, and they have to work closely together. And often what we do at our customers is a mixture between our support and their internal expertise. Sometimes it's really a joint learning also. Because it's the expectation the customers have and also the tools they are using for really then the analytics, they vary from customer to customer. So there's no golden answer for that, do this or that. It's really a learning, but don't be afraid of, everybody has the challenge at the moment, and there is quite some sharing in industry. So we're also trying to utilize these kind of events to share these expertise and learn from each other, simply because this is really new. I mean, having just the tools is beautiful, but making use of them in an effective way is a completely different game.
Yeah, okay. I appreciate it. Thanks a lot.
Hi, Rico. There's another question from Jay from UCT. He mentioned your presentation more focused, high volume, low mix like wafer fab. How about the challenges in low volume, high manufacturing automation?
Yeah. So it's a lot of the things which were given as a rule for a number of years are just vaporizing. So in the past it was, you need automation if you have high volume, low mix factory. So you're doing a lot of the same things. Yeah, it makes sense to automate. What's happening right now is that you also need automation if you have low volume, high mix, and all these different scenarios, even in former low-cost manufacturing like assembly, test, and so on, where you have a lot of people. So there isn't any rule any longer saying manufacturing only makes sense in huge factories in high volume of the same. But the requirements, of course, change. And especially, like already mentioned, if you start to go down to really low volume of single products, you start to get into the challenge having different products in the same cassette. And this is very challenging because an MES is not prepared for the standard MES. So you have to do a lot of components and a lot of deep integration also into the automation to handle that. That is really new, but it's happening already. We have customers who are going down to single wafer lots, but these single wafer lots, it does not mean that there is just one wafer in the carrier or the cassette. No, there are 20 plus wafers, but each of the wafer is a single lot, and that is very exciting. You can't do it manually, by the way. It's impossible. You have to have a deep automation.
Okay. So that's all the questions for now, but do feel free to type in your questions and we may address it in the afternoon breakout sections by Systema.